In this lesson, you will determine the effect that transformations of data have on measures of central tendency and variation, and we'll compare data using measures of central tendency and variation. So a linear transformation is one or more operations performed on a set of data that can be written as a linear function. And what we're going to do is decide what happens to data if you would add or subtract values to the data, or if you would multiply data values. A line plot is a graph that shows the frequency of data along a number line. And central tendency, remember, is the mean, mode, and median of data. So what we're going to do is we are going to look at a set of data. So in this case, we have these data values. And we're going to find the mean, median, mode, range, and standard deviation of the data. And then figure out what's going on if I add 7 to every single data point. So I'm going to show you two different methods that you can use. The first method would be to actually input this into your L1, which I have done here. I have all of these values input into L1. And then you could add 7 to every data point and put that in your L2. So method 1 would be to have two lists. So here is all of my data, that goes in L1, and then I add 7 to every single data point, and that goes in my L2. And then to compare, you do a stat, calc, and your one variable statistics, and I'm going to have this just be my list 1. I go to calculate, and then here I have my mean right here, which is 9. I keep scrolling down, and then here's my 5-number summary, like we had yesterday. Here's my minimum, here's my maximum, so I can find the range, and then there's my median. So the values that I have for this set of data, my mean, which I found by using my TI-84, my mean is 9, my range is 10, my median is 8, and then you do have to look at the data to see your mode. Our mode is 8 also. And our standard deviation, to scroll up to see like that for just a second, is 3.3. Now, what happens then when you go ahead and you do your stat calc of your L2 data, when you calculate that, you're going to get your same, you get a new mean here, you get some new values as you can see as you scroll through. You could actually calculate then all of those values. Your mean now changes, if you notice, to 16. My range is now taking 21 minus 11, so my range is still a 10. My median is now 15. And then you'll have to find your new mode, and then your standard deviation, if you'll look, stays the same at 3.3. Well, our new mode is 15. So what we're noticing here is that when I add 7, and this also works with subtracting if you have a subtraction value, the mean, the median, and the mode, those measures of central tendency that all start with an M, are going to be 7 added. Look at that, 7, 7, and 7. Your range is going to be the same. Your standard deviation is going to be the same. So here's method 2. Method 2 would be to just put your L1 in, find your mean, median, mode, and then do whatever it asks you to do. In this case, it was add 7. You might have a subtract. You might have another adding. So you could actually just use the addition of your mean, median, mode, and then find your range and standard deviation. That might be a little bit easier rather than putting in two lists of data. So you try the example in your notes. Now, in this situation, we are going to multiply each value by 3. So we can't really use that shortcut because with multiplication, you are going to have to input your values. What we know, if I multiply by 3, that it's literally going to multiply everything by 3. So I can actually put this into my L1, which is what I've done here. I've put this data into my L1, and then I do my stat calc, one variable stats of my L1. And what I see here is that I have a mean of 16, a standard deviation of 3.7. I see that I have a range of 12, a median of 16.5, and then I have to find my mode, which is 12 as well. So to find what happens when I multiply by 3, you actually multiply all these values by 3. So what this changes to is a mean of 48, a standard deviation of 11.1, a range of 36, a median of 49.5, and a mode of 36. So in multiplication or division, it'll actually multiply by every single value. So all you have to do is put in your L1 and then use multiplication to find your data. You can try the example in your notes. Now when we're comparing distributions, if the two sets of data seem symmetrical by doing like a histogram or a box and whisker plot, then you would use the mean and the standard deviation to compare them. If the two seem skewed, either positively or negatively, then you would use the 5-number summary. And what I did when you want to plot two sets of data and compare is I actually put my sets of data into two lists. So on my calculator, my L2 is representing Mrs. A's class's quiz scores on that probability quiz. Yeah. And my L3 is Mrs. Titus's class quiz scores. And what I want to do is, as a teacher, I want to look at the quiz scores and see, okay, how does my class compare to her class? You know, are they going to be the same quiz scores? And what kind of variations do we have? So what I'm going to do is I'm going to use a histogram. And so I'll show you Mrs. A's class first. So we're going to do a stat plot, and I turn my plot on, and I'm going to make it a histogram, and I'm going to use my L2. Like I said, I had that listed in my L2 list. And so I do a graph, and this is what the histogram looks like of my class. So as you can see, most people scored kind of in the middle. So the scores were mostly in the 70s or 80s. We had a few really low scores, and we didn't have very many really high scores, as you can see that. But it does look somewhat symmetrical that most people were in the center. So then we'll try Mrs. Titus's class. We'll take a look at that. And let's see how that one compares. I just changed my list. And when I change my list and do my graph, I'm going to have to zoom in here. So here's her class. Most people scored in the middle, just like my class. She had a few that scored lower, and then not very many scoring higher. So I would say that both of our classes are symmetrical. And so as you see up here, if both classes are symmetrical, or both sets of data are symmetrical, we're going to use the means and standard deviations. So to find the mean, you do your stat calc, and in this case, I'm going to do a stat calc of Mrs. A's class, and we find a mean by doing the stat calc. I have those listed here. We have a mean of 84.7, and here we have a mean of 84. So we could say that Mrs. A's class quiz score had a higher average than Mrs. Titus's, but not by much. I mean, those are pretty comparable. Standard deviation here is a 7.5. Standard deviation is a 4.6 here. So what we know that Mrs. A's class was not as close to the mean. The scores varied quite a bit more, whereas Mrs. Titus's class, we know the scores were closer to the mean. It's a lower standard deviation, so most of the scores were consistent. You can use the mean and standard deviation to compare data when they're both symmetrical. Now, if we had some skewed here, then we would use some of the 5-number summaries. So you try an example in your notes of two sets of data.